In this lesson, we're going to look at a third method for solving quadratic equations, and this method is called completing the square. Before we can get into the process known as completing the square, we have to talk about what is a perfect square in terms of trinomials. Now, hopefully you remember that a perfect square, when it comes to numbers, is a number like 25, and it is a perfect square because it is equal to 5 squared. All right, we're going to be looking at trinomials. That's a polynomial with 3 terms that is a perfect square, meaning it can be written as a binomial squared. There are a few examples over here. Suppose you have x squared plus 8x plus 16. If you were to factor this by whatever method you've studied, you would realize that it is x plus 4 quantity squared. So it is a perfect square trinomial because it can be written like this. If you look over here, we have a perfect square trinomial and its factored form, another one and its factored form, and then even one with a fractional value and its factored form. How do you know that these are perfect squares? Well, the first term of each of these is a perfect square. The last term of each of these, and it does have to be positive, is a perfect square. This is 4 squared, this is 3 squared, this is 3 over 2 squared. But the middle term must have a certain characteristic. It must be 2 times the square root of this number. The square root of this number is 4. 2 times it is 8. The square root of this is 3. 2 times it is 6. The square root of this is 3 over 2. 2 times it, the 2's would cancel out, and it's just 3. Our job is going to be a little bit different. We're going to start with the first 2 terms, and we're going to figure out what number must be added to create a perfect square trinomial. In other words, to complete it into a square. That's why the process is called completing the square. One rule that we have to have is that the coefficient of the x squared term must be a 1 in order to do this process. If it's not a 1, we're going to have to divide through by it. So the first problems we're going to have, all we're going to do is take the first 2 terms of a trinomial and figure out what I would have to add so that it becomes a perfect square, and then factor it. After we do a few of those problems, then we're going to use the technique to solve quadratic equations. All right, the first one, it says add the proper constant. So I'm going to add a constant right here to the binomial, the first 2 terms, so that the resulting trinomial is a perfect square. Then I'm going to factor it. All right, but I have x squared plus 10x. Like I said, there is a rule. We're going to always have a 1 be there. In order to figure out what would complete that square, it's a pretty easy process. We're going to take the coefficient of the x term, which is a 10. We're going to take half of it. We're not going to work with decimals, we're going to work with fractions. Half of 10 is 5. Then we're going to take that 5 and we're going to square it for 25. 25 is the number. Now that's actually the opposite process of what I was talking about. Taking the square root of this and doubling it to get this number. Instead, we're going to take half of this and square it to get this number. By doing that, we have completed the square. So you're just going to put in a 25. Now you have to factor it. This is a perfect square trinomial. It is something squared. The square root of x squared is x. We're always going to have the sign from the middle. The square root of 25 is 5. Something else you can do, it's always going to be x plus or minus this number. So right here, the factored trinomial is x plus 5 squared. Okay? All right, let's look at the next one. We have x squared minus 16x plus something to make it into a perfect square trinomial. What's our process? Our process is to take the coefficient with its sign of the x term, take half of it, half of negative 16 is negative 8, square that, and no matter what its sign is, the square will be 64. I'm going to add 64. That's my perfect square trinomial. So 64 goes in the first blank. To factor it, square root of x squared is x, always the sign from the middle, or just go down here, minus 8, which is the sign from the middle and the square root of that number. So you can just, if you've written down your work, it is this number. Don't forget, it is that binomial squared. Let's look at number 3. I have x squared plus 3x plus some blank makes a perfect square trinomial. Take the 3, take half of it. This one's not even, so it's just going to become 3 over 2. Don't use decimals, do fractions. Then we're going to take 3 over 2 and square it. Square the top for 9, square the bottom for 4. 9/4 is the constant that turns that into a perfect square trinomial. What will its factors be? Well, I need an x, and then it is simply this. It's positive, so plus 3/2, quantity squared. It is square root here, square root here, sign from the middle, or just grab this number. All right, we're going to do one more like that, and then we will use it to actually solve quadratics. I have z squared minus z plus something, and I need to figure out what the something will be for it to become a perfect square trinomial. I take the coefficient of the z term, which is an implied negative 1. I take half of it for negative 1/2. I square that, square the top for 1, square the bottom for 4. It will be positive. So 1/4 is the constant I would have to add. What will that be in factored form? Well, I need the z. The number is right here, minus 1/2. Z minus 1/2 squared gives you that. All right, doing that is figuring out what this number is completing the square. But now we want to use that to solve a quadratic equation. This process may have quite a few steps. Let's take a look. I have x squared plus 14x is equal to negative 40. If you're going to use completing the square, there are some format things to look out for. First of all, make sure that the coefficient of the x squared term is a 1. This one is. Make sure that you have the x squared term and the x term on the left by themselves, and any other terms would be on the other side. What I'm going to do now is take that as x squared plus 14x plus a blank that I will complete the square. Because this is now an equation, I have equals negative 40 plus the same blank. All right, how do I fill in the blank? We're going to take the negative 14, I'm sorry, it's positive 14. We're going to take 14 and take half of it, which gives us 7. We will square that for 49. The number that gets added to complete the square is 49. Yes, I've completed the square on the left, but this is an equation, so I have to do the same thing on the right. Because this is a perfect square trinomial, now I will write it as something squared. X, and then remember, the number you need is right here, plus a 7 is equal to, and you get whatever the sum or difference of those is, which in this case is 9. Now, something that you may not have expected is that you had just turned this problem into a square root property problem, because we use the square root property when we have something squared equals a constant, and we do. So square root of this side is x plus 7, and that's equal to plus or minus the square roots of 9. We simplify. So I have x plus 7 is equal to, in this case, plus or minus 3. Okay, I have a rational number. Subtract the 7, put it in front. X is equal to negative 7 plus or minus 3. So I have x is negative 7 plus 3. I have x is negative 7 minus 3. My two answers are negative 4 and negative 10. All right, so this is completing the square. Once you complete the square and write the perfect square trinomial as a binomial squared, then you use the square root property, which was the last lesson. All right, let's do a few more. Give myself plenty of room. All right, I have x squared plus 18x plus 76 is equal to 0. If I were going to try to factor this, I would like it in this form, but I'm not factoring. Square root property requires that you have the x squared, the x term, and a blank equals, and if I get the 76 to the other side, it's negative 76 plus the same blank. So I did two things at once. I made sure the 76 was on the right, and I put in the blanks. The coefficient of x squared was a 1. All right, my process. I take the 18, I multiply it by half, which is 9. I square that for 81. So I fill in with an 81, I fill in with an 81. I have created a perfect square trinomial. The factors are x, and then all you have to do is grab that number, plus 9. Equal sign, and over here I get a 5. It's time to use the square root property, and I've abbreviated that. So the square root of this side is x plus 9 equals plus or minus the square root of 5. Can you simplify? The answer is no, so leave it. Subtract 9. X is equal to negative 9 plus or minus the square root of 5. On a piece of paper, most of the time it would be fine to leave the answer in that format. In my math lab, you would have to put the two separate answers separated by a comma. Negative 9 plus the square root of 5. Make sure you're out of the radical, comma. Negative 9 minus the square root of 5. It doesn't matter which one you list first. All right. Let's look at the next one. I have x squared plus x minus 4 equals 0. Let's get it in the right format for the square root, for completing the square. X squared plus x plus blank equals, when the negative 4 goes over here, it becomes positive 4 plus blank. The coefficient of the squared term was a 1. All right, the implied coefficient is 1 times a half is a half. I need to now square that, square the top for 1, square the bottom for 4. That is 1/4 there, and 1/4 there. I have created a perfect square trinomial on the left. And its factors are x plus 1/2 equals. Now, on the right-hand side, when you start involving fractions, you don't want to have mixed numbers and you don't want to have decimals. So you're going to need to take 4/1 and add to it 1/4. Common denominator is 4. 1 goes into 4 4 times. 4 times 4 is 16, and this one doesn't change. Add them for 17/4. So if you didn't need that, I'm sorry to have wasted your time, but some people are not sure. All right, whatever it takes. You could have said that's 4 1/4 and then write it as an improper fraction. Square root property. Square root of this side for x plus 1/2 equals plus or minus the square roots of 17/4. And I always ask, can I simplify this? Well, I can. So I copy down x plus 1/2 equals. I can't simplify the numerator, so I will shrink the radical to just be over the 17, keeping the plus or minus, but the square root of 4 is 2. And that's no longer under a radical. So now I subtract 1/2 from both sides, and I have x is equal to negative 1/2 plus or minus the square root of 17/2. It will happen most frequently that these two quantities, if you have them, will have a common denominator. So let's use it once. Let's call that negative 1 plus or minus the square root of 17 and put it all over the 2. In my math lab, you would have to list them. Negative 1 plus the square root of 17/2. Make sure your comma is outside the fraction, outside everything. Negative 1 minus the square root of 17/2. And I haven't mentioned it in this lesson, but if you get irrational numbers with radicals, they will be conjugates. All right, we have 2 more examples. Oops. Get some workspace. All right, I have y squared plus y minus 1 equals 0. If my instructions say to complete the square, then I need y squared plus y plus blank equals minus 1, moves over here, needs to become positive 1 plus a blank. All right, the coefficient of y is a 1. Take half of it for 1/2. Square it, and I get 1/4. So I'm going to add 1/4 here and add 1/4 here. Factors, it's going to be y, if you want to, grab it right here, plus 1/2 equals, all right, you've got to simplify this. One thing you could say is that's 1 1/4, and as an improper fraction, that's 5/4. Or you could do it the way I did the last problem. It's 5/4. Square root property. That's y plus 1/2, took the square root, plus or minus the square root of 5/4. Can you simplify? The answer is yes. So I have y plus 1/2 is equal to plus or minus the square root of 5, because I can't simplify that, but the square root of 4 is rational too. Subtract 1/2 from both sides, putting it in front. I have y is equal to negative 1/2 plus or minus the square root of 5/2. Join them together as a single fraction because you have a common denominator. Y is equal to negative 1 plus or minus the square root of 5/2. listing them separately, -1 plus square root of 5 over 2, comma, -1 minus the square root of 5 over 2. Conjugates again. All right, last one. I have 3x squared minus 2x plus 16 equals 0. All right, I notice right away that the coefficient of the squared term is not a 1. So I choose to divide everything by 3 as my first step. That gives me x squared minus 2/3 x plus 16/3 is equal to still a 0. Now I want to get it in the right format. I'm going to keep my x squared, my minus 2/3 x plus a blank is equal to, when the 16/3 goes to the other side, it will be negative 16/3 plus the blank. All right, process is helpful. Take the negative 2/3, multiply it by a half. Those 2's divide out, and I get negative 1/3. Square that, and you get positive 1/9. We're going to add 1/9 here and add 1/9 here. The factors are x minus 1/3 quantity squared. Please remember, it's so easy to get that number if you have it sitting over there. Otherwise, it's the square root of x squared is x, the square root of 1/9 is 1/3, sign from the middle, equals. Okay, I'm going to go off to the side. I have negative 16/3 and positive 1/9. The common denominator is 9. 3 goes into 9 3 times. 3 times negative 16 is negative 48. This one doesn't change. That's going to give me negative 47 over 9. Negative 47 over 9. All right, it's time to use the square root property. So that's x minus 1/3 is equal to plus or minus the square root of negative 47/9. Can I simplify? Yes, that's x minus 1/3 is equal to plus or minus. Now, 47 does not have a perfect square factor, but it is negative. So I will factor the square root of -1, which is I, out of that, leaving the 47. The square root of 9 is 3. Solving for x, I will add 1/3 to both sides, putting it in front. I have x is equal to 1/3 plus or minus I times the square root of 47 over 3. We have a common denominator, so x is 1 plus or minus I times the square root of 47 all over 3. And then, of course, you do have to separate it in my math lab. 1 plus I square root of 47 over 3, comma out there. 1 minus I square root of 47 over 3. Completing the square is a long process. What it gives you that factoring does not give you is the ability to solve all quadratic equations. Quadratic equations that have rational answers like this one, this was number 5, could have been factored in the first place. But those that get irrational answers or imaginary answers could never be solved by factoring. Completing the square also has some value in other areas of higher algebra. So practice these problems.